In this lesson, we're going to learn how to graph quadratic functions. And in this example, our quadratic function is g of x, which is equal to 2x squared minus 4x minus 5. And when graphing quadratic function, you have to be able to find the vertex, the axis of symmetry, the y-intercept. There's always going to be a y-intercept. And there may or may not be an x-intercept, but you need to find those if there are any. And you need to know if the parabola opens up or down. And if there are no x-intercepts, number 6, if there are no x-intercepts, you need to find a point of the graph and use the axis of symmetry to locate the other point. Now, in addition to those 6, you may be asked to find the domain, the range, the interval where the function is increasing, the interval where the function is decreasing, and whether there is a maximum or a minimum value of the function. When finding the vertex, you're going to be using the vertex formula. We're going to remind ourselves about that. But before we even find the vertex, we know right away number 5. So without knowing anything about the vertex, you can tell right away whether the graph opens up or down. So let's look at the information on concavity. So remember, this function is written in standard form, which means that it looks like this: f of x equal ax squared plus bx plus c. So if you recall from a previous lesson, the coefficient of x squared, which is a in this case, determines the concavity, determines whether the graph will open up or whether the graph will open down. And when I say graph, I'm really talking about the shape of the graph, which is a parabola. And so if a is positive, the parabola opens up. The parabola opens up. If a is negative, less than 0, the parabola opens down. All right, so the parabola will open down. All right, so in our case, if you notice, a, which is 2 in this case, is positive. So since a is positive, that means that the parabola for this function, the graph of this function, the parabola will open up. So right away, I know the answer to this. It's going to open up. And the reason, and you don't have to write this down, but I'm just writing it here to remind you why the parabola opens up. But it opens up since a is equal to 2, which is positive. Okay? All right, so that's why it opens up. Now, the other thing, just to let you know, the other thing you can answer right away without finding the vertex, at all, the other one you can find right away is the domain. So I just want to remind you about the domain. Remember, the domain is a set of x coordinates that's on a graph. So if you look at a parabola, if you look at a quadratic function that's graphed, it could open up or it could open down. Does not matter. It could open up or down. Does not matter. But remember, if I'm going to find the domain, of this quadratic function. Remember, the domain is a set of x coordinates, right? So as I go, remember the arrows keep going this way. Keep that in mind. So as I go from left to right, if you look at the one that opens down, if I go from left to right, my domain is from negative infinity all the way, and it never stops, right? All the way to positive infinity. So the domain here is all real numbers. Domain is all real numbers, negative infinity to infinity, all real numbers. So every value of x, every real number of x is going to be represented on this graph. Same thing here. If it's going up, same thing, right? Notice the domain, remember it keeps going, right? Both directions. The domain is going to be negative infinity to infinity. So from negative infinity to infinity, from infinity, negative infinity to infinity, all real numbers for x will be represented on this graph. So the domain of any quadratic function, is all real numbers. Now, in a previous lesson, you may recall when there was a worksheet on finding the domain of rational and polynomial functions. So you may recall that all polynomial functions, all polynomial functions, the domain is all real numbers. So the domain is all real numbers. So if you look at a quadratic function is a polynomial function. So since this is a polynomial function, the domain is going to be all real numbers from negative infinity to infinity. All right. Now, the vertex, in order to find most of the rest of this, you need to know the vertex, or at least part of the vertex. To determine the axis symmetry, you're going to have to know part of the vertex. This numbers 3 and 4, you don't need the vertex at all. All right. But the rest of this, you need the vertex or part of the vertex to answer this. Okay, so let's talk about the Y-intercept. The Y-intercept is easy to find as well. So to begin with, we know that we can find concavity without doing anything else. That's easy to find. You look at the coefficient of x squared. We know we can find the domain because a quadratic function is a polynomial function, and a polynomial function, the domain's all real numbers. We also know that we can find the Y-intercept of this because the Y-intercept, remember to find the Y-intercept, I'm going to write this down. To find the Y-intercept, remember if you look at a coordinate plane, the Y-intercept is where the graph crosses the Y-axis, right? So wherever the graph crosses the Y-axis, you remember the x-coordinate is 0. So to find the Y-intercept, you let x equals 0. So if I go back to my function right here, and let me go ahead and write it. So I go back to my function, 2x squared minus 4x minus 5, and I let x equals 0, I get 2 times 0 squared minus 4 times 0 minus 5. So that's 0. That's also 0 minus 5, which you get negative 5. So you'll notice that in this form, f of x equal ax squared, let me write it right here, f of x equal ax squared plus bx plus c. Whenever you substitute 0 for x, the only thing that's left is your constant. So notice the y-intercept is just your constant. And so every quadratic function is going to have a y-intercept, and that y-intercept is your constant, is c. All right. So my y-intercept is negative 5. The y-intercept is negative 5, and it is always c. It is always the constant. Now, be a little bit careful when I say that. Notice is the constant if it's written in general form, in standard form. Okay, so ax squared plus bx plus c. So this c is your y-intercept. And you know it's a y-intercept because if x is 0, this is 0. If x is 0, this is 0, and you're left with c. All right, so right away, without knowing the vertex, you can answer the y-intercept, you can answer something about concavity, and you know right away the domain. All right, now let's find the vertex. Okay, so let's go ahead and use the vertex formula. So let's remind ourselves about the vertex formula. So the vertex formula, all right, so remember the vertex is a point. Let's call it xy. And let me just remind you. So remember the point here where, see this point here where the parabola decreases and then increases. So the point where the concavity, well, I shouldn't say concavity, but where it goes from increasing to decreasing or decreasing to increasing, that point here, that low point or that high point is your vertex. So it's increasing, then decreasing. It is decreasing, then increasing. So that's your vertex. All right. So that vertex is a point. So let's call it xy. The x-coordinate, remember to find the x-coordinate, you're going to use the formula negative b divided by 2a. So negative b divided by 2a, the opposite of b divided by 2a. So if I look at my function f of x, which equals 2x squared minus 4x minus 5, let's label this. So a is 2, B is negative 4, and C is negative 5. So A is 2, B is negative 4, and C is negative 5. So the opposite of B. So if B is a negative 4, be careful. If B is a negative 4, this says I take the opposite of a negative 4. That's what that says. Take the opposite of a negative 4. And I'm going to divide that by 2 times A, and A is 2. Well, the opposite of a negative 4 is a positive 4. 2 times 2 is 4, and 4 divided by 4 is 1. So my vertex, the x-coordinate is 1. Now we got to find the y-coordinate. Well, once you know the x-coordinate, remember y, f of x is the same thing as y. Once you know the x-coordinate, to find the y-coordinate, y would be f of 1. So you go back into your function, and where we see the variable x, you're going to substitute what you just found. So you're going to find f of 1. So f of 1 then would be 2 times 1 squared minus 4 times 1. Say 2 times x squared. So 2 times 1 squared minus 4 times 1, and then minus 5. 1 squared is 1. 2 times 2, 1 squared is 1. 1 times 2 is 2. And then minus 4 times 1 is 4, and then minus 5. 2 minus 4 is a negative 2, and then 2 minus 5 is a negative 7. So my vertex is 1, negative 7. That's your vertex, 1, negative 7. All right, so I'm going to write that down, 1, negative 7. So if I go to my graph, if I go here now, remember, so this is number 1, and we want to graph the function g of x, which equals 2x squared minus 4x minus 5. So right away, I know my vertex, 1, negative 7. So I'm going to plot the point 1, negative 7 right here. So there's my vertex. And keep in mind, you know that the parabola opens up, right? So do something like this. Now don't draw it yet, because you got to find the x-intercepts. So since, I just want to remind you, since the parabola opens up, and the vertex, which is 1, negative 7, the vertex 1, negative 7 is below the x-axis. Since it opens up, you know it's going to cross the x-axis, right? Since it crosses the x-axis, you do have x-intercepts. So there are x-intercepts, so we have to find those. But before we do that, let's go to the axis of symmetry. So we know the vertex, the axis of symmetry. Let me remind you about the axis of symmetry. The axis of symmetry, and I didn't draw this parabola very well, but the axis of symmetry is the vertical line that goes through the vertex, and it divides again, as I said, I didn't draw it very well, but it divides the parabola into 2 equal parts. Okay, so you have this part is symmetrical about the axis of symmetry. So if I were to draw this a little bit better, let me do that here. So let's do this. So I have this part of the parabola. Here's my axis of symmetry right here. And I'm going to draw the other part. So this is your x-intercept. That distance should be the same as that. So let's kind of make it a little bit better. All right, so there's the parabola. So the axis of symmetry, goes to the vertex. You see that here. And notice it divides the parabola into 2 equal parts. So this part, if I reflected about the axis of symmetry, becomes this part. So here's your vertex. Vertex is I'm going to call it HK. So that's a vertex, HK. Now remember, the axis of symmetry is a vertical line, right? It's a vertical line. So we have to name it using an equation. The axis of symmetry is a vertical line. So we have to call it x equal. It's a vertical line. And it's always going to be x equal this x coordinate, which is h. All right, which is negative b divided by 2a. All right, so going back to our example now that we're looking at, the vertex is 1, negative 7, right? The vertex is 1, negative 7. So the axis of symmetry, if you go ahead and draw your vertical line that goes through the vertex, see this vertical line right here, this dotted vertical line? That's your axis of symmetry. So the axis of symmetry is going to be x equal the x coordinate of your vertex. So if my point of my vertex is 1, negative 7, my axis of symmetry is x equal 1. So that's your axis of symmetry. So in naming the axis of symmetry, you will always need to use an equation. So you have to say x equal. Don't just put a 1 here. Don't say the axis of symmetry is just 1. You must name it. It's an equation. The axis of symmetry is an equation. So you must use an equation. So you got to say x equal 1. So x equal 1, that's that vertical line. Don't say y equal 1. Y equal 1 is a horizontal line. X equal 1 is a vertical line. All right, so now we've answered number 1, we've answered number 2, we've answered number 3. Now let's go ahead and find the x-intercepts. All right, so to find the x-intercepts, all right, let's talk about the x-intercepts. So we got to find the x-intercepts. So remember, the x-intercept is where the graph crosses the x-axis. And when the graph crosses the x-axis, wherever the graph crosses the x-axis, my y-coordinate is 0. So to find the x-intercepts, you're going to let y equal 0. And I know I have x-intercepts because of this. Here's how you know you have x-intercepts. My vertex is 1, -7, right? 1, -7. So 1, -7 is in the fourth quadrant. And I know that my parabola opens up. Well, it opens up, it crosses the x-axis. So there are 2 x-intercepts. So I know it has x-intercepts. So that's how you can tell right away if there are any x-intercepts, just by knowing whether it opens up or down and knowing the vertex. So once you know the vertex, you can tell right away if there are any x-intercepts. Okay, so let's find the x-intercepts. To find the x-intercepts, you're going to set your function equal to 0. You're going to let y equals 0. So remember, here's your function. G of x equals 2x squared minus 4x minus 5. And I'm going to set that equal to 0. So g of x means the same thing as y. So I have 2x squared minus 4x minus 5 equals 0. All right, so this is not factorable, so I'm going to have to use the quadratic formula. So remember, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. And so you're going to need your calculator because these are going to be irrational numbers. So you're going to have to approximate. Okay, so a is 2, b is -4, and c is -5. So I get my x-intercepts will equal the opposite of b. Well, if b is a -4, the opposite of a -4 is a +4. Plus or minus the square root of b, which is -4, but I've got to square that, minus 4 times a is 2, times c, which is -5. All of that's being divided by 2 times a, and a is 2. Before I go on, let me remind you that when you label a, b, and c, if any of these is incorrect, then you're going to have wrong x-intercepts. All right, so it's very important. It's very important that you denote a, b, and c correctly. All right, so let's go ahead and simplify the radicand, or the discriminant. Remember, the discriminant is the part of the quadratic formula that's under the radical. So -4 times itself is 16, so I get 4 plus or minus the square root of 16. A -4 times 2 is 8. A -8 times a -5 is a +40. All divided by 2 times 2, which is 4. So that's 4 plus or minus the square root of 56 divided by 4. Now, 56 is not a perfect square. So at this point, we're just going to approximate. All right, now here's how you can use your calculator, so be careful. So when using a calculator, remember, you were asked to purchase this kind of calculator. So make sure if you have a different scientific calculator that you know how to use it. So we have 4 plus the square root of 56. I'm pressing on square root button, which is here, 56, and then we'll press equal. So that's my numerator. Press equal right away. Just say, what is the numerator equal to? All right. Now notice it doesn't end. It doesn't terminate. All right. So leave it like this. Don't do anything else in terms of rounding off. Don't round off here. Leave it as you see it. Then you can divide all of the numerator by 4. And now let's approximate. So when I approximate to the nearest tenth, let's approximate the nearest tenth. When I approximate the nearest tenth, it is 2.9. So I'm going to say approximate equal to 2.9. So there's one of my x-intercepts. So let's do that again. So you're going to say 4 plus the square root of 56, 4 plus the square root of 56, press equal, that's your numerator. Once you get your numerator, then say divide by 4, and then you get that, okay? Now let's do the 4 minus. So remember there are two x-intercepts, right? Two x-intercepts, we found one of them. Let's find the other. 4 minus the square root of 56, 4 minus square root of 56, press equal, that's your numerator. Divide by 4, and you get to the nearest tenth a negative 0.9. So approximate equal to negative 0.9. So those are your two x-intercepts. There's the work. You had to use the quadratic formula. It was not factorable. So notice we had irrational numbers which we approximated. And so on here, you're going to say x-intercepts. You're going to say 2.9, comma, and then negative 0.9. Those are your x-intercepts. Now notice those approximations, though. Keep that in mind. Those are approximations. So if they're irrational numbers, remember these are irrational numbers. If they're irrational, when I say irrational, I mean this is irrational numbers. So if they're irrational numbers, go ahead and approximate to the nearest tenth. And then we're going to put that on the graph. So here's 2.9. So 2.9 is close to 3, right? Very close to 3 right here. And then negative 0.9 is very close to negative 1. I want you to notice something, and this is important. This is important. The distance from the axis of symmetry to this x-intercept has to be the same from this x-intercept to the axis of symmetry. So make sure they're approximately the same. So the point also is this. If for some reason you get, let's say, 2.9, and then let's say you had negative 1.9. You know, if you put the x-intercept anywhere around this area, you know it cannot be, right? Because this distance, this x-intercept is not symmetrical with the other x-intercept about the axis of symmetry. So the x-intercepts have to be symmetrical about the axis of symmetry. Okay, that's important. All right. Now I want to also say this at this point. Okay, so listen carefully. If you're doing this correct, let's say you did all this correct. Let's check and see that these are correct. So if I add these two numbers, 2.9 plus a negative 0.9, you get 2, right? If I divide that by 2, and I'll tell you why I'm doing 2, divide that by 2. 2 divided by 2 is 1. That 1 right here should be your axis of symmetry. And the reason I divided by 2 is because notice that the axis of symmetry is kind of like that midpoint in it. So here's my, right here. Let me do this. Let me use this. So here is the distance from this x-intercept to this x-intercept. So the midpoint of this black segment here is right here. That happens to be 1. So if I take this number and take this number, so let's call this x1 and x2. If I take x1 and then x2 and divide by 2, I better get that midpoint here, which happens to be the axis of symmetry. The axis of symmetry. Okay? All right, so that's one way to check to see if you used your calculator correctly here. So once you approximate, double check right away. Is 2.9, do it again, 2.9 plus a negative 0.9 equals, divide by 2, and that number should be your axis of symmetry. Okay? That's always going to work out. Okay, now, the other thing we found was the y-intercept, negative 5. So let's plot the y-intercept. So here's my y-intercept right here, right? Okay, so that y-intercept, you also know that this y-intercept, there's another point symmetrical about it. So if this distance is 1, this distance is 1. And then right away, you know your graph. You know your graph. Just draw the graph. You have 1, 2, 3, 4, 5. You have 5 points. You have the two x-intercepts. You have the y-intercept and the point that's symmetrical with it about the axis of symmetry. And you have the vertex. And there's the graph. There's the graph that you needed. Okay? And so there's your graph. And that's all you do. So to get this graph, notice to get the graph, I used numbers 1, 2, 3, 4, and 5. Okay? So this number 6 we did not need to do because we had x-intercepts. Okay, now let's do the rest. Okay, so listen carefully to the rest. For 7, for number 7, for A, B, C, D, and E, you do not need to have drawn a perfect graph like we did here. In order to do 7A, B, C, D, and E, you just need to know the vertex. Notice what I'm doing. I'm just drawing something like this. You need to know the vertex, and the vertex is, in this case, it was 1, -7, right? Which happens to be in the 4th quadrant, and you know it goes up. All right, something like that. So once you know the vertex, then you know the range. Once you know the vertex, I should say, and also whether it goes up or down, then you know the range. So if I go from, remember the range is along the y-axis, so you go from bottom up. So notice when I go from bottom up, I start touching a graph at this point here, right? So that y-intercept right here, that y-intercept is -7. So I'm going from -7 all the way to infinity. So bracket, remember when doing range and domain, you're going to use brackets with your numbers unless there's an open circle. All right, so -7 to infinity. Remember with infinity, negative infinity, it's always parentheses. Okay, so then, remember I'm just using this. I'm not using this at all because I just want to remind you that once you know the vertex, you can go directly to answer these right away. You don't have to find anything else here. You just, well, except for concavity, you just need to know where the vertex is located and whether it goes up or down. All right, so the interval where the function is increasing and then decreasing. And then you want to find the maximum value. All right, let's do the last one first. The last one's easy. So notice that this vertex is a low point, right? This vertex is a low point. So which means it's a minimum. That's a minimum point. So when I ask for the minimum value, whenever we ask for the minimum value, that's that y value. That's that y value. So when I ask for the minimum value of the function, that's that y value. So my y value is -7. That's the lowest point. That came from that vertex right here, -7. So that's all you're right, -7. All right, let's talk about increasing, decreasing. So when I look at the graph, and I go, remember when doing increasing, decreasing, and doing domain, you always go from left to right. So as I go from left to right, notice my function is decreasing, and then it's increasing. So at this axis of symmetry, my function of the y values change. It's decreasing, so decreasing, and then increasing. So you got to ask yourself, though, what is that x value right here? Well, that x value is that 1. So x equal 1. So from -infinity to x equal 1, my y values are decreasing. So my function is decreasing from -infinity to 1. Now remember, when doing increasing or decreasing, you're always going to use parentheses. When doing domain and range, if you have a number, you're going to use brackets. With infinity, -infinity, it's always parentheses. And then where's it increasing? Well, it's increasing in this interval, so that's from 1 to infinity. So from 1 to infinity. And that's it. We've answered everything. See that? So everything has been answered. So that is how you're going to graph this function. G of x equals 2x squared minus 4x minus 5.